My dear students of class 9, I am going to start chapter 8, name of chapter Quadrilaterals, exercise 8.2. Question number 1. ABCD is a quadrilateral in which P, Q, R, S are midpoints of side AB, BC, CD and D. See figure. AC is diagonal, show that S are parallel to AC and S are half of AC. Second, PQ equals to SR. Third, PQRS is a parallelogram. For the solution of this question, we write given. ABCD is a quadrilateral in which PQRS are midpoints of side AB, BC, CD and D respectively. To prove first, SR parallel to AC, SR equals to half of AC. Second, PQ equals to SR. Third, PQRS is a parallelogram. Proof of first part. In triangle ADC, DAC, S and R are the midpoints of sides DA and DC respectively. Then by the midpoint theorem we get SR parallel to AC and SR equals to half of AC. The statement of midpoint theorem is if a line segment joining the midpoints of two sides of a triangle is parallel to the third side and is equal to half of it. We consider this as equation 1, this as equation 2. Now proof of second part. In triangle BAC, P and Q are the midpoints of sides B and BC respectively. Therefore, PQ parallel to AC and PQ half of AC. We consider this as equation 3 and this as equation 4 by midpoint theorem. From 2 and 4 we get PQ equals to SR. Here we see RHS of 2 1 by 2 AC, RHS of 4 1 by 2 AC. RHS of 2 and 4 are equal, therefore LHS of 2 and 4 must be equals. So we get PQ is equal to SR. We consider this as equation 5. Proof of third part. From 1 and 3 we get PQ parallel to SR. Lines parallel to the same line are parallel to each other. Here we see SR parallel to AC in 1 and in 3 PQ parallel to AC. Therefore from 1 and 3 we get PQ parallel to SR by this result. From 5 and 6, this 5 and 6 we get PQRS is a parallelogram. Why? Because a quadrilateral is a parallelogram if its one pair of opposite sides are parallel and equal. This is the answer of question number 1. Now question number 2. ABCD is a rhombus and PQRS are the midpoints of sides AB, BC, CD and D respectively. Show that the quadrilateral PQRS is a rectangle. For the solution of this question, we write given. ABCD is a rhombus in which PQR and S are the midpoints of sides AB, BC, CD, D respectively. To prove PQRS is a rectangle, for this we do construction. We join the diagonals AC and BD. Proof. In triangle DAC, S and R are the midpoints of side DA and DC respectively. Then by the midpoint theorem, S are parallel to AC, equation number 1, and S are half of AC, equation number 2. The statement of midpoint theorem is a line segment joining the midpoints of two sides of a triangle is parallel to the third side and is equal to half of it. In triangle BAC, P and Q are the midpoints of BA and BC respectively. Therefore, PQ parallel to AC, we consider this as equation 3, and PQ is half of AC, we consider this as equation 4 by midpoint theorem. From 1 and 3 we get SR parallel to PQ, we consider this as 5. Lines parallel to the same line are parallel to each other. From 2 and 4 from 2 and 4 we get SR equals to PQ. This we consider as equation 6. From 5 and 6 we get PQRS is a parallelogram. We know that a quadrilateral is a parallelogram if its one pair of opposite sides are parallel and equal. Now, in quadrilateral SMON, SN parallel to MO. Why? Because SR parallel to AC already proved above. Now, similarly, we write SM parallel to NO. From these two results, we write quadrilateral SMON is a parallelogram by the definition of parallelogram in which angle NOM is 90 degree. Why? Because diagonals of rhombus bisect each other at right angle. This implies that angle NOM equals to 90 degree. This can be written angle NSM is also 90 degree. Opposite sides of parallelogram are equal. This implies that angle S equals to 90 degree. Here, PQRS is a parallelogram in which angle S is 90 degree. This angle S is 90 degree. So, PQRS is a rectangle. A parallelogram is a rectangle in which its one angle is 90 degree. This is answer of question number 2. This is last question today. I will meet you next day with another set of questions. Thank you. Thank you very much.